Lesson 11, Polynomials, Complex Roots. In part 1, we have to solve z to the fourth equals 1 for all z. So what I'll do here, I'll take that 1 across the other side and write that as z to the fourth minus 1 equals 0. Now this is z squared minus 1 times z squared plus 1. Of course that is z minus 1, z plus 1. And this, of course, is z plus I times z minus I equals 0. So all the roots are z equals plus or minus 1 and z equals plus or minus I. Right, now in part 2, hence or otherwise solve z to the fourth equals z plus 1 to the fourth. What I'll do here, I'll divide both sides by z plus 1 to the fourth. We'll have z to the fourth over z plus 1 to the fourth equals 1, which is really z over z plus 1 all to the power of 4 equals 1. Now I'm going to let u equal z over z plus 1. So we have u to the fourth equals 1. Now, from the first part, we know that u must be equal to plus or minus 1, or u must be equal to plus or minus I, which of course means that z over z plus 1 must be equal to plus or minus 1, or z on z plus 1 equals plus or minus I. So we'll work our way through each of these. So take the first one, say take z on z plus 1 equals 1. That gives me z equals z plus 1. Of course there is no solution for that one at all. We have z over z plus 1 is equal to minus 1. That gives me z equals minus z minus 1. So I get 2z equals negative 1, which of course gives me that z equals minus a half. Okay, moving on. Z over z plus 1 equals I. This means that z equals I z plus I. Take this across. Z minus I z equals I. Take the z out, so that 1 minus I equals I. And that gives me z equals I over 1 minus I. Rationalize, and we get 1 plus I on 1 plus I. So z equals I minus 1 over 2, or really minus a half plus 1 half I. Now taking the other one, z over z plus 1 equals minus I. That gives me z equals minus I z minus I. So we have z plus I z equals minus I. I think you'll see where this is coming. Take the z out, we get z outside of 1 plus I equals minus I. Z equals minus I over 1 plus I. Then multiply top and bottom by 1 minus I. And that will give me, that's going to give me a minus I and a plus 1 over 2. No, that gives me a minus 1, doesn't it? Of course, a plus and a plus, yep, a minus 1 there. You can watch those I's. And that's going to give me minus a half I, which is the conjugate of this one. Right, and they're the solutions. The solutions are minus a half, and then you've got minus a half plus or minus a half I. Alright, now the otherwise method, what we'll do now, I'll just remove those brackets on the right hand side using the Pascal triangle result. We get z to the fourth equals z to the fourth plus 4z cubed plus 6z squared plus 4z plus 1. Of course, these go out and we get 4z cubed plus 6z squared plus 4z plus 1 equals 0. Now, we can see here that we've got a 1 and a 4. So obviously 1 or minus 1 won't work. So we'll try other solutions. So it's only a trial and error with this one. So we'll try, well, I'll cheat a little bit. I'll try z equals minus a half. So when you put z equals minus a half in here, you'll get 0. This becomes 0. So that means that z equals minus half is a root, which we had from the previous one. So now that means that 2z plus 1 is a factor. And now we'll simply divide z plus 2z plus 1 into this. So 2z plus 1 into all this. 4z cubed plus 6z squared plus 4z plus 1. And now I'll multiply first of all by 2z squared. 2z squared, this will give me 4z cubed plus 2z squared. Subtract, I'm going to get 4z squared plus 4z plus 1, bringing those ones down. Okay, so I'll multiply by 2z up the top, plus 2z here. That becomes 4z squared, plus 2z. Subtract, I get 2z plus 1. So we'll need a 1 here. And there we have it. Now, solving this, we get 2z squared plus 2z plus 1 equals 0. So that means that z equals minus 2 plus or minus the square root of this squared. That's 4 minus 8 all over 4, which equals minus 2 plus or minus 2i all over 4, which is minus a half plus or minus a half I as before.